Hello, grade 10 students. Welcome to our virtual class for the fourth quarter, week 6. I'm Abigail Sarmiento, your science teacher. Our lesson for today is about chemical reaction. Introduction. From the time we get up in the morning to the time that we sleep at night, chemical changes are taking place within us and outside of us. Plants grow through photosynthesis. Foods that we eat are digested by the body. Metals corrode. Raw materials are being converted to useful products. New medicines are being developed. More versatile and cost-effective materials are being made. Various chemical changes that occur around us have significant effects to our environment and consequently to our health. Chemical changes occurring in industries result to products that are useful to us. The wastes we throw continue to undergo chemical changes, and this has an impact on our well-being as well. The irresponsible use for fertilizers, herbicides, and pesticides have negatively affected plants and aquatic life. We continue to pollute the atmosphere with vehicle and industrial gas emissions. Oxygen is vital to life. One interesting reaction which involves oxygen is the production of fire. Fire has fascinated people for so long that the ancient people even regarded it as one of the earliest elements. Fire was so important to them and they describe it as an element that changes everything. The earliest theory about burning was the phlogiston theory. This theory by George Ernsthal in the 17th century stated that when a material burns, it releases a substance known as phlogiston. And this theory was accepted for a very long time. Antoine Lavoisier, through his careful observations from his experiments, debunked the phlogiston theory as he discovered that instead of releasing a substance, phlogiston, a material accurately burns as it reacts or uses with oxygen. This is now known as the theory of oxidation, and this is accepted up to this day. The law of conservation of mass dates from Antoine Lavoisier's 1789 discovery that mass is neither created nor destroyed in chemical reactions. In other words, the mass of any one element at the beginning of a reaction will equal the mass of that element at the end of the reaction. For burning to occur, three factors should be present in proper conditions and proportions. First, fuel. Second, oxygen. The third one is heat. In our country, we are reminded that March is the fire prevention month, as this month signals the start of summer, the season when countless fires break out all over the country. An ounce of prevention is better than a pound of cure, is a motto we will all need to remember. Various materials act as fuel to sustain fire, so various fire prevention and control measures are later as we progress in this. You will get to learn more chemical reactions, why may bring benefit or harm to life as well as to the environment. Reactants and products. Reactants are substances that are used up to form new substance in a chemical reaction. Iron reacts with copper sulfate or CuSO4 and forms iron 2-sulfate FeSO4 and copper. Second, magnesium combines with oxygen gas O2 to produce magnesium oxide. Hydrogen peroxide H2O2 in the presence of manganese dioxide or MnO2 produces water and oxygen gas. Fourth, acetic acid CH3COOH and sodium bicarbonate NaHCO3 produce sodium acetate with the release of carbon dioxide CO2 gas and water. Copper sulfate CuSO4 reacts with sodium hydroxide NaOH to produce insoluble copper 2 hydroxide CuOH2 and while the products on the right. A double arrow is sometimes used. This indicates a reversible reaction. This means that as they are produced, the products are also converted back to reactants. Following are the types of chemical reaction. Figure 1 shows the combination reaction. Figure 2 shows the decomposition reaction. Figure 3 shows the single displacement. And the last one, figure 4, shows the double displacement. From their data, 4 types of reactions are used: combination, decomposition, single displacement, and double displacement. Relate that these are the basic types of reaction. The last 2 are special types which involve specifically acids and bases. Acid-base reaction and oxygen and hydrocarbons combustion reaction. Steps in balancing equation. Step 1. Write the unbalanced chemical equation. Make sure you have followed correctly the rules in writing formulas of compounds. Second step. Take note of the elements present in the reactant and product side. Third. Count the number of atoms or atom of each element present in the reactant and product side. Fourth step. Apply the law of conservation of mass to get the same number of atoms of every element on each side of the equation. Balance chemical equations by placing the appropriate coefficients before the symbol or formula. Do not change the subscript of the formula in an attempt to balance the equation, as it will change the identity of the components. Example, for the product of 2NH3, what number represents the coefficient? 2. What number represents the subscript? 3. What element is represented by the letter H? Hydrogen. The last one, how many atoms of H do you have? 6. And that is it for today's lesson. Please don't forget to subscribe to our YouTube channel, GAITF, or log into your account at lcms.gaitf.com so that you can answer the quizzes and activities given by the teacher. Thank you for listening.